You might find it hard to believe that a small workshop with rudimentary conditions can actually produce reliable industrial rollers. The pre-treated raw materials, due to their low quality, need further purification and decomposition into smaller pieces of steel, which can now be put into the melting furnace. Don't be fooled by this fooey equipment, which is over 50 years old. Although old, its performance remains stable. The only drawback is its relatively high oil consumption, as the equipment burns 50 liters of heavy industrial oil for every 100 drill cycles. They are currently working diligently to melt and improve the quality. The old man at the mold preparation station next to the pure steel section wasn't idle either. Considering the relatively large roller size, if traditional sandbox molding were used, air bubbles might easily form in the middle of the bow and arrow. Therefore, a centrifugal casting process is used here. The power system is equipped with a single steel diesel engine. I feel it should be an imported machine. Now, the expensive raw materials from the chain casting process have arrived at the best casting state. Soon, the molten iron is filled with a special transfer bag. You can see the centrifuge. Both sides are equipped with casting gates to improve work efficiency and allow the bow and arrow to be molded as a single piece, increasing overall strength. The centrifuge will continue to work after casting is complete. The high-temperature molten iron is gradually cooled and solidified. Then, using a forceful method, the bow and arrow are removed from the mold and placed aside to cool to room temperature. Due to the limitations of the plastic column mold, the entire roller cannot be formed by plagiarism. The smaller shafts on both sides require further processing. The assembly process begins with simple heating of the shaft tube. The thermal expansion and contraction of the tube makes the installation much easier. Finally, a hammer is used to tap it back and forth, resulting in a qualified roller in a rough, unfinished state. Next, we went to the adjacent machining workshop. Here, there are extra-large low-speed lathes. A 28-year-old craftsman pre-adjusts the machining parameters, and the machine can automatically run, machining the roller diameter to the design requirements. Because the bow and arrow are relatively large, the processing efficiency was low, and it took a whole day to finally machine the shaft to the design dimensions. However, it cannot be shipped yet. The roller surface still needs to be machined with small drainage grooves to facilitate the juice flow during the customer's juice extraction process. The grooving machine used here is quite professional, accompanied by an electric motor. With back and forth movement, grooves of uniform depth gradually appear. However, I feel that the drainage grooves machined here are a bit too shallow. I don't know how the subsequent processing will be. Now, the finished rollers are placed in a temporary mounting position. Unexpectedly, the workshop is still mass producing this product.